Alright, here with example 8, you're going to do something pretty similar to example 7, except what you're going to do is you're going to compare a couple of different balances. So you're going to compare and determine whether you'd rather have something, if you're talking about money, compounding every quarter or continuously. And then you're going to find out what the difference in your accounts are going to be. So whenever you look into putting money into a savings account or some kind of other money fund in the future, you might want to ask how many times it's compounded, because then you can tell, say, well, hey, Lafayette Bank Trust is going to continuously compound my savings, and then Wells Fargo, they're not going to compound at all. So you can determine where you're going to make more money by not doing anything and just plugging it into your bank account. So if this is compound quarterly, that means we're going to use A equals P times 1 plus R over N to the power of NT. And we're going to say A equals, well, they put $25,000 in. Wish somebody do that for me. 1 plus, now your rate is 8.25%, so that means 0.0825 all over. Now if it's compounded quarterly, there are 4 quarters in a year. There's also 4 quarters in a dollar, if you didn't know that. Then we get 4 times 26 out here. So when we plug this into our equation, if we simplify what's inside our parentheses, we're going to take 1 plus 0.0825 divided by 4. I should probably put parentheses around here. Let's go back over and more. So insert parentheses here, and then our answer is a 1.0206. So 1.0206, and all of this is to the power of, that's going to give you 104, because you're 4 times 26. So if you plug all this into your calculator after 26 years, see how much money you make. So 25 grand to times 1.0206 to the power of 104. Holy moly. It's a big chunk of change. Looks a little bit like my yearly income here. So we get $208,000, 410 and 5 cents. So 208,000. 400, I already forget, 410 and 5 cents, and that is if you do nothing with that money. Nice little chunk of change there. Now let's compare that with something that could be compounded continuously. In this case, you're going to use a different formula. This is where you use your PERT equation. So we still have our principal is 25,000. E, don't plug anything in for that, that's just a function on your calculator. R is 0.0825 and your T is 26. So you can just plug that into your calculator the way it's written. So we're going to say 25000, second LN button, and then in parentheses we're going to take 0.0825 times 26. And you get a little bit more money, not a whole lot, about $5,100, but you've done one extra $5,100. So we're going to say this is $213, 551 and 3 cents. So if I was to compare my banks, I think I would rather have something that's compounded continuously. But that's just me.